Hello friends, in this session we'll see what is meant by prime factorization and how to do prime factorization of a number. What are the different methods for prime factorization? Well, we'll start with one basic thing. If I multiply 3 with 4, we'll get 3 4s are 12. This being known as the multiplication of 3 and 4 or known as the product of 3 and 4. In this, 3 is known as a multiplicand and 4 is known as a multiplier, while 12 is known as a product. But these 3 and 4, they are also known as factors. They are known as the factors of this product. What is the product? Product is 12. And in this case, this 3 and 4, they are known as the factors of the product, means factors of the 12. Well, 12 also can be written as 2 multiplied by 6 or 2 6 are 12. In this case also, what are the factors? What are the factors of product? What are the factors of 12 are 2 and 6. Again, 2 and 6, they are known as the factors of 12. Well, in the previous video, we have seen that how to find the factors of a number by listing method and how to find out SCF and LCM using this listing method. But listing method, it's a time consuming, cumbersome. So we take the help of prime numbers. What are the prime numbers? We have seen how to find out the prime numbers from 1 to 100 by using sieve of Eratosthenes, and how to find out how to extend this idea of sieve of Eratosthenes for the larger number we have also seen. So we now know what is meant by prime numbers. Prime numbers are the numbers which can be divided by 1 and the number itself. These numbers are known as the prime numbers. Now we will come back to the idea what is meant by the prime factorization. Well, 12 I have written in the form of a multiplication of 3 and 4. I have also written 12 as a multiplication of 2 and 6. In this case, we will know that this 3, 4 and 2 and 6, even 12, the number itself is a factor of itself. So factors are 3, 4, 2 and 6. But one thing to be noted is that this 4 is not a prime number. It is in a table of 2, it can be divided by 2 and it's not a prime number. Even in this multiplication also, 6 is not a prime number. So what is the problem of it? What is the problem? Well, the problem passes is that these are not the prime numbers. So if I write the product or multiplication, that if I split this 4 and if I write 3 multiplied by 2 multiplied by 2, because 2 2s are 4, and if I write this as 3 2s are 6 and 6 2s are 12, now this explaining a number in the product of prime numbers is known as a prime factorization. So what basically we are doing in the prime factorization is that to show a number by the multiplications of the prime numbers. Again, we are come to this idea that what is meant by composite numbers and what is meant by prime numbers. I already told you that composite numbers, they are made up of multiplication of prime numbers. So prime numbers, they are important. So this method of expressing a number in the multiplication of prime numbers is known as the prime factorization of numbers. So you can see that all the numbers, that 3, 2, 2, they are the prime numbers. In this multiplication, no number is a composite number. This is known as a prime factorization of that particular number, 12. Even in this case, I can write 2 is a prime number, no doubt, but 6 actually I can write as a multiplication of 2 and 3, and I again get the prime factors of number 12 as 2, 2 and 3. As we know that the multiplication is associative, it is also commutative. We can multiply the numbers in any sequence. So it doesn't matter which number comes first, which number comes last, but in the multiplication, we should have all the numbers to be prime number. So we are going to show a number as a product of few numbers. We are taking an example of number 36. Well, 36 can be expressed as a multiplication of 6 and 6. 6 6 are 36. But you can see that both 6 and 6, they are the composite number. So I am going to split 6 again as 2 multiplied by 3 and 2 multiplied by 3. Multiplication sign will be there in between them. So now 2 multiplied by 3 will become 6 and 2 multiplied by 3 will become 6 and 6 6 are 36. Now in this case you can see that all the numbers 2 3 2 3, they are the prime numbers. Now we express the 36 as a multiplication of prime numbers. This is known as the prime factorization of 36. But is it possible for a large numbers to find out the prime factors in this way? For a small numbers, two-digit numbers, it is easy way for finding the prime factors like this. But for large numbers, it is difficult. For that, we are having one method which is known as a factor tree method. So let us see what is this factor tree method. Factor tree method. So in factor tree method, well, we will write down the given number. As there is 6 in one's place, this is a composite number. So I am going to put it in a box. Then next, well, I will start dividing the given number with the lowest possible prime number. The lowest possible prime number is 2. This number is being even 2. I will divide 36 by 2. Now, what is the quotient in this case? The quotient is 18 because 18 to the 36. Now you can see that 2 is a prime number, so I am going to circle it, and 18 is a composite number, so I am going again put this number in a box. Well, next thing, again we are start dividing the next number with the next prime number. Get the quotient. What we get the number as a quotient, we will divide that number by the smallest possible prime number. If not possible by 2, we'll go for 3. If not possible by 3, we'll go for 5. If not possible by 5, we'll go for 7, and so on. But in this case, I can divide 18 by 2, and when I divide 18 by 2, I will get 9 as a second factor. Well, 3 as being a composite, being a prime number, I am going to circle it, and 9 is a composite number. I am going to put it in a box. Now, well, can 9 be divided by 2? No. 3? Yes. 3 3s are, I am having 3 3s are 9. Now you can see that both the factors of 9 are 3 and 3. Both are prime numbers. So I am going to put them in a cycle. Now, I will write the 36 as, now you will see that all the numbers that are circled 2, 2, 3 and 3, they are the prime numbers and they are the prime factors of 36. See, 2 multiplied by 2 we will get 4, multiplied by 3 we will get 12, multiplied by 3, 12 multiplied by 3 we will get 36. So now we express the number 36 as a multiplication of prime numbers. We'll see one more example of number 45. So as we are going to see that the number 45 is being a composite number because there is a 5 at the end, one's place. So it is divisible by 5. So we will start dividing it. We'll see whether it is possible to divide it by 3 and 5. First of all, we will try for 2, not possible. Whether it is divisible by 3. See, 4 and 5. When we add them, we will get 9. And 9 as divisible by 3, the number is also divisible by 3. And also we can divide this number by 5, but we will first of all try to divide it by 3. And when I divide 45 by 3, I will get a quotient as 15. So we are having two factors of 45, 3 and 15. 3 being a prime number, I am going to circle it, and 15 being a composite number, I am going to put a box on it. Fine. Next, 15. Is it a prime number or a composite number? It's a composite number. Fine. So, can I divide 15 by 3? Yes. 3 5s are 15. So now I got two factors of 15 as 3 and 5. And both are prime numbers. So I am going to put a circle on them. Circle them. And now we got no more numbers which can be further divided into factors as their prime numbers. Now we can express the number 45 as 3 multiplied by 3. 3 multiplied by 3 will make a 9, and 9 5s are 45. So now we have expressed the number 45 as a multiplication of prime numbers. This is known as a prime factorization of 45. Let us take an example of one more number, 120. Number 120 being 0 at ones place, it's an even number and can be divided by 2. So it's a composite number. So I'm going to put it in a box. Fine. Then, well, I will start dividing it with 2. 2 being a smallest prime number. When I divide this 120 by 2, I will get the quotient as 60. And now we got the two factors of 120 as 2 and 60. 2 being a prime number, I am going to circle it. 60 is a composite number and I am going to put it in a box. Fine. What to do next? Now again we will try to divide the 60 with the smallest possible number, smallest possible prime number, that is 2. So when I divide 60 by 2, well, I will get the quotient as 30, and 30 as 0 is there is an even number and can be divided by 2. So it's a composite number, so I am going to put it in a box. Next thing, well, I will again try to divide it the smallest possible prime number, that is 2. 30 is divisible by 2, so I get a quotient as 15, and now the 2 again a prime number, so circle it. 15 a composite number, put it in a box. Now I will try to divide 15 by 2, not possible, so I will go for 3, and 3 5s are 15. So I got two factors of 15 as 3 and 5, and I see that both are prime numbers, 3 and 5. So we'll stop here because no more further factorization is possible. So we got now the numbers 2, 2, 2, 3 and 5 as the prime factors of 120, and 120 can be written as multiplication of 2, 2, 2, 3 and 5. You can see that 2 2s are 4, 4 2s are 8, 8 3s are 24, and 24 5s are 120. Or we can go in another way. For example, 5 2s are 10, and 2 2s are 4, 4 3s are 12. 12 and 10 when multiplied will give you 120. So we are now find out the prime factors of 120 by the factorial method. Let us go for one more method which is known as a combined division method or a common division method for prime factorization. Now let us see what is meant by common division or combined division method. Well, we are going to follow the algorithm, the division algorithm. So the same algorithm, what is meant by algorithm? Algorithm means one method. In a regular division method, we are going to put the dividend in this sign also, and we are going to place divisor over here, and we write the quotient above the dividend. But in this method we are doing a separate thing. First of all, we are going to draw a vertical line and then a horizontal line. So we are going to make it like a cross, like a T, and now we are putting 120 on the right upper corner. Now we'll start to divide 120 by smallest possible prime number, that is being 2. 120 can be divisible by 2. So at the quotient we will get 60. Now again divide 60 by smallest possible prime number, that is 2. We will get quotient as 30. Well, 30 can be divided by 2. So again we are dividing 30 by 2, and we will get quotient as 15. Now 15 cannot be divided by 2. So we will go for a 3. Yes, 3 5s are 15. Now I got the quotient as 5. Now 5 can be divided by 5 itself. So 5 1s are 5. stop here because now we got the 1. And now you can see on the left hand side what we got as a 2, 2, 2, 3, 5. Now, if I write 120 being the multiplication of 2, 2 and 2, 2, 2 and 2, multiplied by 3, multiplied by 5, multiplied by 3, multiplied by 5, I will see that I got the same prime factors as we got by the factorization method. And being it's the quickest method, very fast method. Now you can see that again 2 multiplied by 2 is 4, 4 3s are 12, and 2 multiplied by 5 will become 10, and 10 multiplied by 12 will become 120. So we got all the prime factors of 120. Well, we are now going to extend this method for one more 3-digit number. Take an example of 248. 248. So we have to find out the factors of 248. Naturally, same method again, we are going to put it in a cross in such a way that we'll having the number on the right upper corner. Now, we'll start dividing it with the smallest possible prime number. Well, we'll see that 4 plus 2 it's 6 and 8 will be 14, so it's not divisible by 3, but it's divisible by 2 because 8 is there and it's an even number. So I got in the quotient as 124. Again 124 is an even number and is divisible by 2, so I am going to divide 124 by 2 and I got 62 as a quotient. Okay, 62 being the even number, I am going to divide it by 2. And now I got the quotient as 31. Well, 31 can be divided by any other number, any other prime number. Try for 2, try for 3, try for 5, try for 7. No. 11, no, not possible. 13, not possible. Because 31 itself is a prime number and cannot be divided by any other prime number. So we'll stop here because we got now 31 can be divided by 31 only, and 31 ones are 31. Now what we got here as a 2, 2, 2 and 31 are the prime factors of number 248. So if I multiply 2 with 2 with 2, I will get 8. And when I multiply 8 with 31, I will get 248 as the required number. So now we have prime factorized one more 3-digit number, that 248, and this is the quickest method of prime factorization. Well, I can make the prime factors of 2 or more numbers simultaneously with this combined method or a common division method. That's why it is named as a common division method. So you give me 2 or 3 numbers, I am going to divide it commonly with this combined division method or a common division method. Let us take an example of it. It is said that to find the prime factors of 125 and 25 simultaneously at the same time. So how to use this common division method for finding out the prime factors of 25 and 125 simultaneously. Let us start. Again, same thing. We are going to put the numbers in the right upper corner of this cross. We'll begin to divide it with 2 not possible, 3 not possible. So we are directly jumping it to the 5. Now I know that 5 5s are 25. So I get quotient as 5. Now I am going to divide 125 by 5. And when I divide 125 by 5, I get 25 being a quotient. Because 25 5s are 125. Now, both you can see that 5 and 5 25s are 5 5s are 25. So I can divide both the numbers with 5 simultaneously, and I get 5 1s are 5, and I will get 5 5s are 25. Okay. Now we will stop here because we now get the prime factors of both the numbers. Because 1 and 5 being the prime numbers, 5 and 5 being the prime numbers, they further cannot be factorized. So we'll stop here. Now we'll list down the factors of 25 and 125. What are the factors of 25? The factors of 25, we got that 5 and 5 because we got the quotient as 1 for 25. So 5 multiplied by 5 are the factors of 25. And what are the factors of 125 then? Well, we'll go for 5 multiplied by 5. And now we will go horizontally. And I see that what is the quotient I got for last division of 25 by 5 is 5. And that quotient is also a prime number. So we get the prime factors of 125 as 5, 5 multiplied by 5. 5 multiplied by 5 multiplied by 5. We got the prime factors of 125. So you can see that how easily we can divide two. Even I can use 3 numbers, I can do 4 numbers, the division of 4 numbers with the help of a common division method. And we can find out the factors combiningly of all the numbers simultaneously. Question may be there in your mind that what is so important about this prime factorization? How it makes easy to find the factors of a number. Well, take an example of 36. I have jotted down all the prime factors of 36 and 120. Prime factorization of 36 and 120 we have already seen. We'll take the multiplication of these two numbers, that is 2 multiplied by 2. That will become 4. And you will find that 4 is a factor of 36. 4 9s are 36. Now what I am doing is to take the multiplication of these two numbers. 2 multiplied by 3, that will become 6. And 6 is 36. So 6 is also a factor of 36. See, so we are getting the factors of 36. We got 4 is a factor of 36. We got the 6 as a factor of 36. Okay, now we'll take extend this multiplication. Now we'll take multiplication of these three numbers, 2 multiplied by 2 multiplied by 3. That is, it will become 2 multiplied by 3, 2, 4, and 4 multiplied by 3 will become 12. And now, what is a 12? 12 3s are 36. Again, we get that the 12 is a factor of 36. Now, we will take multiplication of last two prime numbers, 3 multiplied by 3. And I found that 9 is also a factor of 36. 9 4s are 36. Okay, now what to do next? Well, I will take the multiplication of last three numbers. In this multiplication, 2 multiplied by 3 multiplied by 3. That is 9 multiplied, 3 3s are 9, 9 2s are 18. And I found that 18 is also a factor of 36. 18 2s are 36. See how easily we can find the factors of a number with prime factorization. Naturally, the multiplication of all the prime numbers in prime factorization will give the same number. So 36 is a factor of itself. But 1 is a factor of every number. We already know that. Let us take an example of 120. We'll take the multiplication of first two numbers, and I found that for 120, 4 is a factor. Now, if I take the multiplication of first three numbers, I will get 8. Okay, now next thing, I will take the multiplication of these two numbers, 2 and 3. That is a 6. So I found that 6 is also a factor of 120 because I can divide 120 exactly with 6 without leaving any remainder. Now I will take the multiplication of these three numbers. 2 multiplied by 2 multiplied by 3. That is 4 3s are 12. So 2 multiplied by 2, 4, 3s are 12. So 12, I know that 12 10s are 120. Now, I will do multiplication of these two numbers. 2 5s are 10. 10 is also a factor of 120. Fine, very good. Then, I will take the multiplication of 2 multiplied by 2 multiplied by 5. So this will become 2 multiplied by 2, 4, and 4 5s are 20. So 20, I know that the 26s are 120. So 20 is one more factor. So finding the factors in this way becomes easy. Okay, I will multiply last four numbers. 2 multiplied by 2, 4. 4 3s are 12, and 12 5s are 60. And I know that if I double the 60, I will get 120. So I got 60 as a factor of 120. Well, I will remove this, and what I am going to do, I will take the multiplication of these three numbers, 2 multiplied by 2 multiplied by 2, and that will give me 8. And again I am multiplying 8 with 5, and I get 8 5s are 40. 40 is a factor of 120 because 40 3s are 120. So we can find out the factors of numbers very easily with the help of prime factorization. It helps in any other thing? Yes, definitely. Well, what we are going to do is I am taking what are the common factors from the prime factorization of these two numbers. Let us underline them. 2 and 2. We are having 3 and 3. We are having again 2 and 2 being the common. So I found that 2 and 2 are common for 36 and 120. 2 and 2 common for 36 and 120. 3 and 3 is common for 36 and 120. If I take the multiplication of 2 multiplied by 2 multiplied by 3, it will become 12. So 12 3s are 36, and I got that 12 10s are 120. Means both 36 and 120, they are in a table of 12. So what we got here? We got a common factor of 36 and 120. What is so special about this factor? Well, we'll see that 12 being a factor of 36. If I found the next factor of 36, it's 18. But 18 is not a factor of 120. If I try to found 18, whether 120 comes in a table of 18? No. So we can say that 12 is the highest common factor of 36 and 120. So what we got is the highest common factor, SCF, being the 2 multiplied by 2 multiplied by 3, and that comes to be 12. So we come to the conclusion that finding the highest common factor and lowest common multiple will be made easy with the prime factorization. Well, we already know that the multiplication of highest common factor and lowest common is equal to product of given numbers. Product of numbers. So with this relation also, we can now find out LCM. We can now easily find out LCM.